Hello again. For those who came later and didn't hear my introduction, my name is Daniel Obodovski. I run a company called Silent Intelligence. And tonight we're going to be talking about data analytics, value of real-time data. And I'm really delighted to invite on stage Bob Familiar and Curt Cornum from Inside Enterprises.
Good to see you. I'll scoot in.
All right.
Took the scenic route.
How many of you guys familiar with Inside Enterprises? Perfect.
It's like we're molding clay tonight.
Excellent. Curt and Bob, why don't you guys introduce yourselves and also talk about Inside Enterprises?
Sure. Bob, I'll let you start.
Hi, so I'm Bob Familiar. I'm the National Practice Director for a division within Insight called Blue Metal. So we were a company founded in 2010. Our focus was on modern applications at that time. If you can think back, it was mobile applications, tablet applications, but the company grew. We're now focused, about a third of our business is focused on IoT and Advanced Analytics. So I manage the principal architects in the organization, and our job is to engage our clients, understand their challenges and their vision, and help them build a strategy for their digital transformation. How are they going to take advantage of this next generation of connected devices and data and actually drive business impact?
Good. Hi, everybody. I'm Curt Cornum. I think it had my official titles, Vice President and Chief Architect for Insight. My boss calls me the Chief Geek at Insight, which I think was a term of endearment. I'm hoping that it was. I won't bore you with my whole bio. If I'd love to connect with everybody on LinkedIn. And Bob kind of mentioned, he's part of the Blue Metal team, which is part of a bigger Insight organization. It's a approaching $6 billion organization. Bob and I are part of the services org, which is about a $500 million organization. So we have very much a focus on services, full stack solutions, and we'll probably get into some of those solutions here in the next few minutes.
Awesome. Thanks, guys. So let's maybe kind of put some definition around to figure out what we're talking about when we talk about advanced analytics. Maybe let's agree on some terms. Maybe you guys can define it, what it is.
Yeah, I think we have different views. So Bob, why don't you start?
Sure. So, as I'm sure you're all aware, I mean,
I think we'll converge eventually.
We will.
Yeah.
He's coming down the stack. I'm coming up the stack. It'll make sense.
So I'm very much focused on, obviously, the data. IoT is all about the data. So once you have a connected manufacturing floor or a connected fleet or a connected person or a connected medical device, whatever it is, you're going to start to gather data. And I think in the earlier session they were talking about how often you gather the data. Is it continuous? Are you gathering data occasionally and so on? But at some point you're going to end up with a lot of data. And that information will build up and essentially produce a historical record, and which is a very powerful tool. So we'll talk about that. But at some point, you're going to want to start to analyze that information. So typically, you're setting up things that are called a cold, warm, and a hot path as this data is flowing in real time. And the data is going to end up in a repository, so it can be visualized on a dashboard or in a mobile application. It's certainly going to be archived off, and when you archive the data off, and that historical is typically used to continuously train your data models and make those data models smarter and smarter. And then there's the act of actually identifying conditions in real time and doing alerts and notifications. So then once you've got that historical record, you can actually start to build these data models. These data models can be used to do things like predictive analytics. So that is what advanced analytics is about, is saying, okay, we have the historical record. We've been doing historical reporting for a long time. But once you have real-time data combined with historical data, you can build models of the environment that you have connected, whether it's a connected product, maybe a water pump or a water fountain, a water treatment system. These are all things we've done. We've done chillers, we've done soil, we've done medical devices. Whatever this connected thing is, you're going to now have the historical and the real time, and that's where data science comes in. So this is again one of the challenges that we all have as organizations that are doing services, and as folks like yourself who may are looking to take advantage of advanced analytics, is finding those really smart people who know how to do data science. I've told my kids, learn data science. That's what you need to do if you want. And so that's my biggest recommendation for everyone in this room. Tell your kids to become data scientists. But they're going to then build these models, and these models are going to be a combination of this telemetry that's coming in, that's telling you about it's sensors that are connected to the space or the thing or the person. They're going to tell you that real-time telemetry, but you may need to also combine some ambient feeds like the weather, or we did one example of a customer that has industrial chillers on the top of buildings. So yeah, we were getting the compressor and the motor information, but we also needed the water quality in the area that system was deployed, and the weather, because it was sitting outside. All of that the data science could use to then build the model that said, here's how quickly the pipes will corrode, and here's now we can actually predict when the system will need maintenance. The software can do the prediction and then automatically create the work order that sends the field technician, routed out to that customer to do the maintenance. So that's an example where a combination of historical real-time data models can allow you to create this new business model, which is a connected field service, a predictive field service model. You can charge differently for that than you could if you were just doing reactive maintenance.
Thanks.
I couldn't do a better definition than that. That's why I let him start. What I meant by kind of top of the stack and coming up the stack, I think everybody's probably familiar with the IoT stack in some regard. And I tend to spend my time coming up the stack. I really focus on network and security and the endpoints and those parts, where Bob's really focused on the software side. And just give you one example use case that we've done for clients is around doing anomalous traffic detection using advanced analytics to actually look for breaches in networks. And probably not a day or week goes by where we don't hear about another breach. But what's shocking isn't the breaches, because they're going to continue to happen as long as we have humans behind the firewalls that are clicking on links and things like that. It's really the time to detection that is shocking in a lot of these cases, right? You hear 100 days, 6 months. It's just amazing how long it's taking for some of these breaches to get detected. So there's a lot of advanced analytics products and solutions coming to market to solve that very specific problem. So we've helped clients do that, and it basically uses the techniques Bob talked about around getting data sets and models and understanding what that network heartbeat, that foot or that fingerprint looks like, and then it starts looking at that traffic and trying to do pattern matching and things like that, and through that it can do anomaly detection. And the reason it matters for IoT is most of these IoT devices, they have an operating system, so they're a target for hackers, but they're not usually part of the endpoint protection that we've had for years around normal devices. And so they kind of sit in that spot where we're not looking at them the same way. There's not a human sitting there, and so they're vulnerable in a much different way. And there's so many of them that there's no way that humans could actually look at that traffic and do the detection. So that's why the advanced analytics is important for that.
Thanks, Curt. You were just talking about applying the data analytics on a network traffic. Mm-hmm. But let's look at some examples from the more of an IoT form. Let's maybe pick a use case. Bob, maybe you could talk about something.
Sure. So we've done a lot. So as I said, we've been doing IoT and Advanced Analytics for about 3 years. We've done one that was in one of the early ones was in a factory setting. What was interesting there is this company manufactures industrial X-ray guns, for lack of a better term. But basically, you point it at a material, and it will tell you if it's got cracks or fissures and so on. And they're used in other manufacturing settings or looking at infrastructure to look for damage. Well, they had a situation where they were sourcing parts, from overseas, and they were manufacturing it here in the U.S., putting all the parts together in the U.S. And this device had an embedded operating system. So one of the benefits they had was they could, right there in the firmware that they were putting on the device, they were running tests. So that was great. They were manufacturing it. They were putting it into hot conditions, cold conditions. They were running their tests, but then they were manually gathering the data at the end, and then they were shipping the product out. Took them about 3 months to gather all the test data and go back and analyze, usually using Excel or something like that, and dig in and try to find out what was the quality of these components that actually got shipped, what were the test runs and the success failure rates and so on. And they would discover they'd have to do some recalls because they actually had, put some, not components that weren't performing well into shipped product. So what we did is we said, why don't we do this? Why don't we run the test? We'll connect to the cloud from the firmware itself, and we'll push the results into the cloud. We'll do the analytics and be able to tell you instantly what your success failure rate is for that particular run. And now, the main thing they wanted is that big dashboard outside the factory floor, so they actually see that it was data visualized for them, so they could actually know in an instant, okay, we've done a bad run. They know which components are the issue. They swap them out. They run the tests again. So now, of course, the benefit is the products they ship out the door are much higher quality. They don't have that recall issue anymore. So that's just an example of operational efficiency, right? You're using real-time data and analytics to improve the efficiency, in this case, of the quality of their product and the recall situation. Other clients are looking at using data to create new lines of revenue. So the example with the chillers, that customer was looking for an opportunity, because today they ship these giant industrial chillers and they sit on tops of buildings all around the world. And they get about 5% of the maintenance contracts. Their distribution channel gets 95%. Now, they don't want to eat too deeply into the distribution channel, but they wanted more than 5%. They'd like 20 or 25%. But they had to come to market with something that was a different cost structure for the end customer, and something that was different than what the distribution channel was offering. And they also wanted to include the distribution channel in that model so that they weren't completely cutting them out. So being able to have the connected chiller, as I described earlier, where we're getting the motor, the compressor, all the telemetry, as well as the ambient information, the water quality and the weather, we were able to build a data model that said, okay, here's when that chiller needs to be maintained, so to minimize downtime. And that allowed them to come to market with a subscription predictive maintenance service contract model that they were able to essentially sell that to their customers, increase the amount of services revenue they were bringing in, and provide this much higher quality of experience to their customers, which, by the way, their customers were able to enjoy the benefits of the dashboard that we created, because it ended up being a SaaS application in the cloud, multi-tenant. So distributors could log into it, the customers could log into it, the employees could log into it, each one only seeing the data and the systems they were allowed to see. So that was a benefit, where they built this software ecosystem around the product, made it a subscription model, and were able to monetize that. So either you're driving towards operational efficiency, or you're looking for this opportunity to drive net new revenue.
Can I just
Yep,
add on?
totally.
A kind of interesting business aspect of that is this expectation now that your product is connected and visible, that now you have to manage it, right? So the folks that are consuming that product have that expectation. And a lot of folks just are not, their organizations are not built for that today. A lot of times the product gets shipped out and it's a much different relationship with the client. When these things are connected 24/7, the expectations are totally different. So we've had to help clients, as we've helped smart enable these products, we've had to help them also understand what that means to their business and from a support standpoint.
And in those cases, what part of the data was real time versus historical? Actually, in both of those cases.
Yeah, go ahead.
So it's always a combination. In fact, our data scientists, when we're talking with the clients about how we want to be able to structure the solution, one of the first questions is, do you have data? Because the data scientist wants to see the historical record. They want to look for the peaks and the valleys in that data. They want to see where the anomalies are. That's going to help them start to think about structuring the model. So you need the historical data. If the historical data doesn't exist, you're going to connect something up and you're going to run it for a while. So you build a historical record. Typically in these IoT scenarios, we're gathering a lot of data, so you're building up a historical record pretty quickly, and the anomalies should begin to pop out. So you need the historical data, and then from that, you're going to then have the real-time data coming in. So the combination of doing analytics on the stream, which is referred to as stream processing, looking at all the messages coming in from the environment that you have connected, or the thing, running some analytics on that stream in real time, either saying for each individual message, we're going to look at the range of values, or we're going to gather the data coming from the stream for 5 minutes, then we're going to apply a linear regression, and then we're going to look at the result of that. And as a result, then you decide what am I going to do? Certainly, you're going to archive off all the messages, so it's kind of like a routing exercise now. You certainly want to put enough information into, let's say, a NoSQL or relational database so the dashboard gets updated. But if you captured an anomaly, you want to send that over to what we refer to as a notification and alert backplane. And you are going to trigger from there some business logic that's going to say, okay, now we need to update the CRM system, kick off a work order. I need to send out a text message, send some email, do a voice message. All of a sudden you're getting the word out that this situation exists, and you're going to do that alert. One example is we did a solution with Becton Dickinson, and it was a Bluetooth-enabled diabetes patch. This product is primarily sold to children who have diabetes, and the parent and the school nurse definitely would like to know if the condition of the child, immediately, like 24/7, right? So we said, okay, so we're going to treat the mobile phone as essentially an edge gateway. So the Bluetooth patch is connected to the phone. So we're gathering IoT data coming through the phone as it's connected to the cloud. But on the phone as well is an application. Excuse me. And the application is a front end for an artificial intelligence chatbot. So what we're able to do is gather the information about the condition. The child eats something at school, the blood glucose spikes, the patch does its job, it injects the medication, everything's fine, but the parent's notified, the school nurse is notified, they're informed of the condition in real time of the child, whether everything is stable or not. And in addition, the parent or the nurse or even the child can actually ask a question of the chatbot to say, okay, this just happened, what do I do next? The parent could say, my child just had an episode at school, what should I feed them when they come home? What should their activity, how should their activity change now? So it's got, in the back end, it's an entire repository of information, medical information on diabetes with a bot framework technology built on top of that, along with machine learning. So the combination of all three of those things create what we experience today probably with some commercial products where you can kind of ask it a question and they'll tell you an answer. But this is oriented towards creating an experience for what we refer to as the care unit. The child, the parent, the nurse, creating an experience for them that is going to get right to the point and allow them to feel good that the child is in a good condition, give them steps of what they can do post this event, and using that combination of historical data, medical data, real-time data, and this emerging technology around what's referred to as cognitive APIs. So I think that combination is really compelling.
Yeah, it's a great example. And what I was going to ask is, it's generally costs a lot more, it's a lot more effort to capture the real-time data, right? What are some of the examples where it's absolutely justified and you should go to all the means in capturing the real-time data?
Yeah, I think you just mentioned one. Another project that we did was around I call it, folks kind of called it the smart fridge, but it's basically a vaccine dispenser. Mm-hmm. And imagine, you're trying to create this vaccine dispenser that's going out to developing countries where clean power and just power is not a given. So you have to deal with that issue. And then some of these vaccines are $1,000 a pop or even more, and they have to be within plus or minus 6 degrees centigrade or they go bad. So in a case like that, you need to know right away whether something has happened in terms of the environmentals, so that you don't dispense those vaccines, because then it could have an adverse effect. So that's probably another one that's almost an immediate type of thing. Of course, at the same time, you're gathering a ton of other data that's not necessarily the real time, but it's helping in terms of inventory control and efficacy of overall. Do you need to order more product? All of those things. Once the thing is connected, there's a lot of other side benefits that you get from having it connected in the first place.
So would it be fair to say that having access to real-time data actually opens new opportunities for new business models, new revenue models?
It absolutely does. And what's interesting is almost every client to a T, when we first go in and we create, let's say, the minimal viable product, the very first thing we're going to do for them, we get their product connected and we're starting to gather the real-time data. The first thing they want is remote monitoring. Just show me things are connected and healthy. Now I want to do that predictive maintenance. But then at some point, a light bulb goes off. and we refer to this as like the X factor, right? The customer has this idea and says, wow, now that we see all this real-time data, imagine if we could do this. They talk to us, is that possible? And the answer is always yes, of course. But the point is that they are realizing something that they didn't realize before, because now they have line of sight to things which are happening real time with their environment, with their factory floor, with their connected product, with the people that are connected, all of that. One example is that we did an application for Indianapolis Motor Speedway. They came to us and said, we want to create an application for our fans, the race fans. We said, cool, we'd love to do it. We're known for creating really compelling user experiences, the applications. That was like the first thing Blue Metal was known for. So they wanted a really killer application on a mobile and tablet device. So we did that. But we said, look, to really make this cool, it'd be great if we could have the information from the cars. Can we get information from the vehicles themselves as the race is going on? They said, yes, we'll negotiate with the pit crews. We don't want to give away, give data that. So there was a negotiation. They said, yes, you can have this data, but not that data. But we put 9 gateways around a track, and we were gathering the data in real time. And so we then had this very beautiful application that would show you who's in first, second, third, or fourth place. It could also start to tell you, who had the fastest lap, the fastest pole time. But then we used machine learning to predict who's the hot driver. So we essentially turned the app into a video game. We said, okay, what we can do is we can predict this driver here who's in 11th place based on the fact that they, let's say, had the last 3 fastest laps. We predict they'll be in 3rd place within this many laps.
Wow.
So now the race fans like, this is awesome. So now I can choose who my favorite race driver is. I can follow them. So guess what the light bulb moment was for Indianapolis Motor Speedway? We can sell stuff through this app, right? So, they were just going to give the app away, but now they could turn it into an e-commerce experience, and they could sell the hats and the T-shirts and tickets to the next race. And, they're thinking about things like fantasy racing, all right? So if fantasy football wasn't enough, we're going to go fantasy racing, all right? So, but this is where all of a sudden all these new opportunities blossomed because they saw what real-time data could do.
This is a great example. I could visualize it immediately. But Curt, you and I exchanged on the email regarding the challenges of capturing and transmitting data.
Right.
So if, and I know it's always hard to talk about without too much specifics. Let's imagine an industrial customer, and they say, okay, we've been collecting historical data, but now we realize we need to start capturing real-time data. What kind of advice, what would you tell them they need to start paying attention to, or what would be their next steps?
Yeah, well, Bob mentioned the minimal viable product, right? That's normally a technique that we have used to try and get folks started and kind of get a quick win out of these things, because a lot of this is around the sustainability and scaling these IoT solutions, as I'm sure everybody understands. And so that's probably the biggest recommendation. I know Bob and his team have actually done where they'll emulate the data. So even if whatever the device is that's trying to generate the telemetry, we can actually emulate that telemetry to show what it would look like in a minimal viable product to help them kind of sell that internally. So before they actually go and do the work around some product management or product, if you have to do some kind of modification. So that would be, I think, always is our advice, is to start out with an MVP on that, and you get a quick win and you shamelessly promote that win internally, and then you go try and get funding to scale it out and do those types of things.
But how would somebody even go around selecting which network they should pick, or what hardware they should choose, and so on?
Well, we actually, Bob, you can probably he can do it better around the blue sky engagement than we do.
Yeah.
Because he lives and breathes the blue skies all the time.
Yeah, so the one thing we have to state, when the solutions that you can create here are really compelling, and the key though is to get to that point, you have to have a strategy. And I tell our clients, many times we'll go into meetings and they'll say, tell us about the technology. We want to know about the sensors. We want to know about, does this device, will it work? It's I tell them the technology works. Yes, there'll be some engineering that has to be done, but believe me, the technology works. It's working in many situations today. But let's step back a second and discuss, if we were to do this, what's going to be the impact to your organization? So for example, many of these solutions, especially if you're building a software ecosystem around a product, or you want to incorporate your partners into this software ecosystem of your connected environments, you're now in the software business, all right? And very likely you're in the SaaS business because you're building cloud-hosted software that is multi-tenant, which means you now have to understand, and you have to be able to operate that day to day. You have to be able to, at some point, if you're working with my team, we're going to be done, and we're going to hand it off to your team, and they're going to now be responsible for, continuous delivery, which is, doing the bug fixes and rolling out the changes and updating the UI and operating this thing. If it's SaaS, it's very likely it's a 24/7 digital experience. Multi-tenant, which means many different parties could log into the same application and see different data and different capabilities. How do you architect that in from the ground up? If you've never done anything like that before, if your teams have never done that from an IT perspective, that's something we want to know before we even embark on this journey. It may mean that you're going to go to market differently than you did before. What's that impact to the sales and marketing and to the finances of your company? All of a sudden, this idea of we just want to gather some real-time data is having a ripple effect through your organization, and that's why you hear folks use this term digital transformation. What they're saying there is, if you leverage real-time data to create a software ecosystem that now becomes a digital experience for your employees, your partners, and your customers, you're now in the software business. And so if you were never in the software business before, you now are, and that is going to transform your business and your culture, and you may need to hire new skill sets, retrain. There's just a lot that now gets triggered as a result of going through that. So we use a process called Blue Sky, which is the company name was Blue Metal, so we called it a Blue Sky Blueprint Blue Metal, which is incredibly cute, I think. But anyway, but it's a serious thing. So the Blue Sky is, let's actually first start, before we talk technology, let's understand the business, let's do the operational gap analysis, let's understand who in the organization will be affected if we were to gather the data and we were to do all this modeling and create these software dashboards and mobile apps and data visualization and automate business processes. Who's going to be affected? Do we have all the stakeholders in place? Do we have them all at the table? We have them all on the same page? Help our client create a program internally inside their company that's going to drive this effort. And typically, outcome of the Blue Sky is a lot of our design team gets involved, and we create some pretty compelling collateral that's in the form of customer experience maps and project plans and customer journeys and a bunch of these assets that, interestingly enough, get then taken most likely to the board of directors of our clients, where they are being used to probably go, okay, this is what we're going to do. We have a cost model. That's another one of the things we develop out of the Blue Sky. Here's how much it's going to cost to build it. Here's how much it's going to cost to operate it. We understand the impact to the organization. We have a strategy. We have a plan. And we need budget, right? So that's usually it's all the information you need in order to line up the budget, and it's having the strategy in place. So now it's all about execution. So after that, then we get into the blueprint, which is the architectural piece, and the blue metal, which is what we refer to as our high-velocity software development lifecycle. So being able to do that strategy piece up front, critical to the success of these projects.
This is excellent. Thanks, Bob. So there are two questions that I wanted to ask you and kind of follow up on the case study that you described before in the industrial space. So there was a case that you were talking about where a distributor was capturing 95% of the maintenance contract, services revenue, and then themselves only 5%, and then decided to increase it. Question number one is, how did the distributor react to that, and how did they end up being part of the equation and getting some benefit from that or not? And question number two, how was it implemented technologically?
So, yeah, it's a delicate balance, and so the key is if you're going to build a software ecosystem, is to include the partner in that. So now the distributors, would actually be able to log into the dashboard, and they would see all the chillers that they sold into. And so they were getting the data for the chillers that they sold, and they were getting the predictive analytics to allow them to offer a proactive service contract. So it became more of a co-opetition rather than competition. So that's the key, is to involve them, give them the same tools you're using, allow them to leverage the software to transform their own business. So that's a part of it. The technology that was used is, I have to be honest, the vast majority of the work that we've done is on the Azure platform. The reason is Microsoft's done an incredibly good job of providing platform as a service capabilities in Azure for IoT and advanced analytics. So if you're familiar with cloud, there's infrastructure as a service. This means I want on-demand compute and storage. I just want to stand up VMs. I want to deploy my own software there. I'll manage the operating system and everything on up. Platform as a service is Microsoft does all of that for you. You just say, I want the service and I want it this scalable. Give me the endpoints, give me the connection strings, and I'm going to then integrate it into any additional custom software that I happen to write. And I can then deploy that custom software within containers into the platform as a service runtime environments. So the benefit is, from an operational perspective, is that you're not having to manage infrastructure. You're not managing VMs, networks. You're not managing operating systems, security patches, all of that. Microsoft does all of that, but you get to leverage things like IoT Hub, which handles all the device management and device communication. Stream Analytics, which does the real-time stream processing. Blob storage, SQL database, Cosmos DB, Data Lake. We use all the different storage mechanisms. There's machine learning, Hadoop, and Spark can be used for the analytics. And of course, you want to build dashboards. You can build custom dashboards. You could use Power BI. You can do mobile applications using their Xamarin Stack, which gives you a cross-platform mobile. So Microsoft's done a fantastic job of providing all the software tools that you need for creating these connected solutions. And in the cloud, it's platform as a service, which simplifies the day-to-day operations. And so that's the benefit our clients have seen from it.
Just to follow up a little bit, more generally, these platforms that are out there, and we're going to talk to quite extensively tomorrow on that, and these as-a-service models, they're really just destroying this linear supply chain that we used to have around the OEMs and distribution and resellers and the end customers. And we're not immune to it either, right? And so we see it within, with our industry, within the services IT industry. I'm assuming that everybody here sees it to some extent within your businesses as well. And so what Bob mentioned there, I think, is that ripple effect we're seeing across, especially these as-a-service models, just changing the relationship that we all have. So who was a competitor may be a partner in the future, and one that was a customer, we may actually be partnering with them to go to market together on a product. So it's an exciting time, but it's pretty disruptive, and you got to be pretty nimble to and flexible to be able to deal with how these partnerships are changing today.
Indeed. I'm really enjoying the discussion, but I'm hearing we're starting to run out of time. So I wanted to wrap it up with two more questions. First is security. Security is obviously a big topic. And arguably the IT and the enterprise has a good understanding of security. However, a lot of IoT projects are being implemented by the operations. What kind of maybe words of advice or thoughts you would like to share when folks are implementing IoT projects to address security?
Yeah. I'll just go quickly, and Bob, I'll let you finish out. One is, I kind of mentioned some of the stuff around the advanced analytics on the anomalous traffic detection, which is an area that I think most folks will go there. I don't think a lot of folks are there. The products are maturing pretty well. But it's around Forrester called it a zero trust mindset anyway, around networking, which is really you don't trust anything, anybody, any application, any device as it crosses different trust boundaries. And I don't think a lot of folks, again, will get to a pure zero trust environment anytime soon. Some folks might feel that they're there, but I think they should adopt a zero trust mindset today and at least work towards that and just take that zero trust. I call it the hunker down, in my corny way, I just call it the hunker down strategy, where you just don't trust anything that's being connected to the network. And but there's, I can give some folks additional information. Bob and I will be around through the duration of this event as well.
I'd recommend changing the default password.
That would be a good place to start, wouldn't it?
From password to something more cryptic.
1, 2, 3, 4.
Awesome. And my last question is more any part of a parting thoughts on when companies are embracing data analytics solutions. Where should they start and how should they go about it?
Bob, I'll let you take it.
Yeah, I think the key is to step back and determine whether or not you've got the right team in place, understand the impact across the organization, get all the stakeholders in place, work with a firm probably very much like ours, which can help you build the strategy, the roadmap of how you want to execute your plan. Build the plan and build the execution plan. And start with a minimal viable product. What is the minimal thing that you could actually build? And not proof of concept. Proof of concepts get thrown away. A minimal viable product means you're building a software product that you're going to operationalize. It is going to be used by end users, whether they're the employees or you're going to open it up to customers and partners in a SaaS model. But what's the minimal thing you could do and bring it all the way into production and see value from it, that actually is going to have a demonstrable business impact. That's the upfront planning and strategy and architectural work that needs to be done. Then we can quickly go build it, and once that's there, it'll become pretty obvious that that it has value or it needs to be tweaked or it doesn't have value. You'll know, but you'll have done it on a timeline that's pretty reasonable. Within a 4 to 6 month period, you could have an MVP stood up, and you could be measuring it and determining is this the right direction for us? And then if it is, then we see our clients then going to version 2 and version 3, and they just get into a high velocity software release cycle where they're just rolling out new features month over month.
Curt, any parting thoughts?
No, I appreciate the opportunity and everybody's attention today. And like I said, we'll be around the duration of the event. If we can help you guys in any way, we'd love to chat with you.
Awesome. Thanks a lot, guys. Curt, Bob, thank you.